Hello everyone, welcome to this session of Engineering Materials Lab. In this video, we'll be learning about the experiment and calculations for determining dielectric constant of the given samples. In the session, we'll be talking about the experiment setup or the apparatus which we are going to use for the measurements, the procedure for the measurement, the actual measurements which are undertaken, the precautions that we need to take to ensure that there is no error in the measurement. We'll talk about the data which we'll acquire from the measurements and the calculations that we will need to undertake. So we start with the experimental setup. For determining the dielectric constant of the given samples in the lab, we have the dielectric constant kit with a CRO attached to it. Within the dielectric constant Within the dielectric constant kit, we already have the standard capacitor and the inductor along with the audio oscillator which will be used to charge the capacitors. If I look closely at the dielectric constant kit, what I find is that it has three options available for the standard capacitor: SC1, SC2 and SC3, where SC1 and SC2 are inside already available, and SC3 is something which we can put in from the outside, and we can toggle the value of SC, the standard capacitor, between these three using this particular switch. The dielectric cell is on the outside of the system. The dielectric cell is on the outside of the dielectric constant kit, comprising of these two gold coated brass plates, and we need to put in our samples which are cut in a similar shape, which is a round shape, within these plates to make the complete dielectric cell and do the measurements. And we also require a vernier caliper to measure the radius and determine the diameter, the thickness of the given samples for which we want to determine the dielectric constants. So if I look at the procedure, first of all we should switch on the system and make sure that CRO is showing a AC wave, a sine wave which is not attenuated. Afterwards, that dielectric cell assembly should be constituted by putting in the sample inside it. We switch on the system again and we choose the standard capacitor which has similar value as to the samples that we want to measure. Once it has been done, now what we do is we toggle the switch between VDC and VSC and measure the voltage, and whatever values we get, using those values we determine the value of CDC and taken the value of C naught which we have determined from using the vernier caliper measurements of the radius and the diameter, and we obtain the dielectric constant by putting in the calculated value of CDC and C naught. During an actual experiment, we use vernier caliper to determine the radius of the gold-coated brass plates and the thickness of the sample. We need to remember that as per the formula, the calculations will work if we determine and put in the formula for values of thickness and radius in meters. Okay, together these two values will be giving us table 1, which will be used to calculate C naught for all individual samples, because we have 4 different samples. All the 4 samples have different thicknesses, so we will be calculating C naught for individual samples, all the 4 samples. Afterwards, once the cell has been assembled, we should make sure that using the cal we are getting no attenuation. Okay, so using the cal, we should make sure that the sample is neither too large nor too small. By making sure if it is too small, the sensitivity of the instrument will be decreased, and if it is too large, it will get attenuated, which will on further calculations make sure that all the data is actually coming out to be wrong. So this is something which we need to ensure. Once we have ensured that there is no attenuation, then we introduce samples inside the within the two plates of the sample. Here we have put in the plywood sample. Now what we need to do here is this particular switch S1, we can see it very much here that it is toggled between VSC and VDC, so the value given here changes. And during the measurements again, you can see it very clearly here, the AC signal is available. It is AC signal is available. This should never show as if it has become attenuated or it becomes too low. Okay, so we toggle between the two and we take the two measurements, VSC and VDC. When we are making this measurement, we have to make sure that my sample plates are coinciding one on top of the other. Okay, they should not be placed as if they are, as in like the as it is shown in the figure. They should coincide. Okay, because if they do not coincide, the actual area of the capacitor will decrease. Okay, so this is very important to remember while making these measurements, to ensure that your dielectric plates are exactly on top of each other. So using this, we make the measurements for all the four samples. We have the first table and the second table. The first table comes from the measurements using the vernier caliper, and the second table comes from the measurements using the dielectric cell. And CSC is the capacitance of the standard capacitor that we have used in this system. These are the formulas which will be used to find the values of C naught, CDC, and hence dielectric constant for all the four materials. Thank you.